So last step, MA is the sum of the forces. Put little vectors on here, and nothing changes. It's the same equation. However, what we have here is mx double prime then is equal to the x component of, that was weird, the x component of the forces here. And my double prime is equal to the force, but the y component. And if we write this as a vector in MATLAB, I'm going to write it with MATLAB's ease here, this would be F1. And this would be F2, the first and second components in MATLAB. That's where we're headed with this. Net force is equal to Fg plus F rod. This was, I'll use MATLAB brackets now, minus mg. And this one was our r times negative u. This one had nice and easy components. These components were a lot more complicated. So it might be easier not to write these. But the key thing is we can add those up and get a net force as a vector. And so what that gives us is that x double prime, going back from the top, here we go, is going to be 1 over m times the net force x component. And y double prime is going to be 1 over mass times the net force y component. That's how it's going to work. And with exactly the same sleight of hand we used at the beginning of this class, we're going to turn those second derivatives into first derivatives. So let's add a page here. We're going to create 4 new variables. We have 2 second order equations, so now we need 2 times 2, 4 new variables. The way I usually do it, and I think it's done in the other, it's typically done this way. We're going to create a new variable that's our position. And our second variable is going to be the derivative of that. So it's x position and then x velocity. And then W3 is going to be what? Y, exactly. That's going to be our y position. And W4 is going to be y prime, which is our y velocity. Once we've built those, we can build a system of equations simply by finding the derivative of each new variable. Notice I'm using W here because y is already taken. Y is naturally our vertical position, so what's another variable we haven't used yet? Let's use W. So then the derivative of W1 with respect to time is the derivative of x, which is x prime, which is, in the new variables, what altogether? W2, exactly. We also get another freebie. The derivative of W3, well, the W3 was y. When we take a derivative, we get y prime, and altogether it is W4. Fantastic. Then we get the fun ones. There we go. The derivative of W2, well, W2 is one derivative already of x, and then we take another derivative, so we get 2 derivatives of x. It's going to be 1 over m times our net force, the x component. And last but not least, our fourth value is going to be the second derivative of y, which we found from our differential equation is going to be the sum of the net forces, but the y component of that. And so that is what we're going to implement and simulate with next class.